Hey guys, EST here, and if the power goes out, can I run this full-size refrigerator off of this absolutely terrible battery and this beast of an inverter? Let's find out. So this right here is a 2,000 watt Jupiter inverter. Not a great brand, but it's kind of a solid workhorse one. I think it's a Harbor Freight model. And 2,000 watts continuous, 4,000 peak. When they say peak, they mean for a quarter of a second, so I might as well just ignore that rating. It's okay at running motors, so it should be okay at running compressors. Now, I forgot to mention this, but this is super important. I say it's okay at running motors, and what I mean by that is it's a modified sine wave inverter, and those are safe for motors. The compressor in a fridge is basically a motor. Now, smaller, cheaper inverters use a square wave inversion, and that will overheat and overspin a compressor or a motor and cause bad things to happen. It could break, explode, light on fire, all this nastiness. Now, the top-of-the-line inverters use a true sine wave inverter, but those are really expensive. If you got the budget, definitely get one, but modified should be fine. Would I buy a better one if I had a choice? Absolutely, but I got this one for dirt cheap. Speaking of dirt cheap, this is a 215 cold cranking amp, 12-volt battery that's meant for lawn and garden use, so rotting lawnmowers. It's lead acid, so I'm about done holding that up with one hand, but I have absolutely no idea how many amp hours of capacity it has. My guess is not much. Also, it's at least 5 years old, probably closer to 10, but I did just charge it up. It only charged to about 12.2, so let's see if we can get away with it. I did pay, I think, either 25 or 30 bucks for it when I first bought it. Now, I did bring all these different gauges of cables, different hookup styles, bring terminals, battery terminals, all that stuff. A lot of these are like a proper gauge for running something like this. But we're just going to try jumper cables for my car. They are suspiciously light, they're way too long, and I don't think they're meant to be used for more than about a minute or two. So will that introduce too much resistance? Well, let's find out, because I think if somebody was just improvising this and all they had was an inverter and they never bothered to wire it up, who would ever do that? I can't imagine somebody would fail to properly wire up an inverter that they bought months ago. Nobody would ever do that. But let's pretend that was the case, just like we're pretending that we're not just at my friend's apartment so that if we blow up the fridge, we could just say it happened and it would be covered. Let's say you just decided, well, what's the thickest gauge I've got? Jumper cables. Let's go. Now, this right here is the model number of the fridge. It's a GE Hot Point or Hot Spot, something like that, HST17BB MFLWW, made in 2003. Now, mysteriously missing from the entire back here is a plate saying how much electricity it draws, which I could have sworn was required by law. Maybe it's on that thing that I'm not touching, maybe it's under that thing that I'm definitely not touching. I thought it would be easier than this, considering my stand-up freezer would only pull 65 usually, and 140 watts peak. So I could run that off of anything. So 215 cold cranking amps, let's just call it 200 because they like to exaggerate stats and this thing is ancient. At 12 volts, we'll do the math. You multiply them, that's how many watts it can do. So this could get really close. Also, I'm a little bit worried about the capacity of this thing. Now, I looked at every manual, the spec list, the manufacturer's website. I could not find how many watts this draws continuously when the compressor is at max. I found this Energy Star guide, which says 465 kilowatt hours per year on average. So you divide that by 365 days, and you get about 1,250 watts for 1 hour on average of usage per 24-hour period. However, how much does it use when it's on? And I don't know, how many minutes per hour the condenser tends to run for. My guess is not that many, but I hear it all the time, so I'm not sure. But the problem is, let's say I don't have an inverter, I don't have a battery, I just want to set up one of these systems like you probably do. Do you get the $200 lithium battery, or do you get the $40 piece of junk battery that I have? Well, it could do 200 amps at 12 volts, that's 2,400 watts, right? So we're good. In theory, in perfect conditions, right off the shelf, brand new with no aging, at an absolutely perfect temperature with perfect hookups, with perfect wires. This is why I want to switch down the way I'm going to do it and just see if it works, because I don't want to find out when there's an ongoing power outage that it doesn't work. And the specs were a little optimistic. Or me buying the inverter used, it's got a little aging to it, and now we've got a problem. And I will tell you, the difference between a high-quality 800-watt inverter and a 2,000-watt inverter are enormous price-wise. So why overspend when you could be buying other things in your prepper budget? So you want the output capacity, and you want the runtime capacity of the batteries, to be appropriate but not overkill. And how do you do that without enough information? So unfortunately, I actually just had to resort to plugging it into a power draw meter that I have and finding out. And those things are really expensive. So check yours ahead of time, and if you can't find it, call the number on the website. They legally have to provide you with this information. Or find a friend with a power meter. Now, one last thing about that. I metered my freezer in that video where I ran my freezer off of a car battery. It said it drew like 135 watts, and I kept metering it at like 62. Turns out it has two modes. If it detects it's really, really warm, like you just plugged it in or there was a power failure, it will kick in at double and just run that condenser like crazy, drawing double the wattage. Regularly, it just runs at 65 so that it doesn't wear out. So even hooking it up to a meter to measure it didn't really give me an accurate amount. Now, according to initial research online, the average refrigerator is between 350 and 780 watts, and this is not one of those dual door enormous ones. So could I get away with an 800 watt to 1000 watt inverter? Maybe. So those are the main things to watch out for. Let's get back to the real world testing and me almost burning down my friend's apartment and burning my hand. Now you might hear that the compressor on the fridge is actually running right now. The whole time I set this up, it wasn't running. And that's the key to how long can you run this appliance for. I have absolutely no idea what the amount of time, like the percentage of time in an hour that runs for. So that's why refrigerators are complicated, but let's turn it on. Okay, so we got power, and let's just start powering a laptop. There we go, charge up our spare testing T580 from work. There we go. Oh, okay. It's drawing almost nothing. There you go. On the power level, it's almost nothing. I did put a drill up to this before, just plugged into the my car battery, actually, with it running, and ran a drill at 100%, and this thing was like 2 bars. So very capable inverter, very high capacity. So it's working. We've got power. Now, since this battery, we're concerned with the amount of cold cranking amps it can supply at one given time, I'm going to test it again with that drill, but I don't actually know how much... Uh-oh. Well, that's not good. We've already got a low voltage warning. Let me diagnose this real quick. Alright, I finally found my voltmeter. Let's see what's going on. Well, 11.48 volts, that's not enough. Boy, that's annoying. Alright, well, I'll be honest with you. I pretty much knew that ahead of time. This thing was at 2.2 volts when I started charging it, and it charged up in less than an hour. Yeah, it's pretty toast. I'm gonna go get the $5 trade-in on this thing and go buy a proper battery. Alright, guys. We're doing it right this time. I got the biggest, baddest marine deep cycle battery that I could find. 680 amps. Now, I peeked at the website, and I'm pretty sure I know what their capacity is, but I'm not going to ruin it for everybody. Plus, never trust the numbers. Always try it yourself. Also, electricians, we're doing it right this time. There you go. No more jumper cables. Right after I test it with jumper cables. But the problem with this is we'll never know if that battery was big enough. But I had to know. So I got a 340. Let's find out. Alright, we're all wired up, and it's running right now. I don't think I should unplug it while it's running, so I'm going to have to wait a second. But there's a chance that when I plug it in, it won't then start running because it'll be at the proper temperature. But that's the whole point. I want to know how many hours this can run for, if at all. And if it's already cold enough, well, then we'll include that in consideration. So that right there, is a pair of melted jumper cables. Do I even need to really say it? Could I put 2 and 2 together? Yep, they're actually still warm. Had to unplug them, so good thing I have lidocaine. They didn't touch. I don't, this can carry 20, 30, 40 watts forever. I don't know what happened. There's no breach in the shielding. I don't know what happened. I don't know how the inverter with nothing plugged into it and just turned on and idling in 3 minutes with no load could do this. I don't know. They weren't touching. I even looked. They weren't touching. They might say, why didn't I film it? I was a little busy. This ain't fake. This really hurts. I've had worse burns. This isn't too bad, but let's do it the right way. Don't do this. So, what happened there? An inverter with just fans running is like 10 watts. There was no load, nothing plugged in. I know the inverter works, and right now it still works. 30% of the battery's energy was dissipated in about a minute. We would have seen the magic smoke come out of the inverter if that was what failed. When I ran over, both ends were melting, both handles, both ends. So that means it wasn't like a narrow crimp point in the copper from like damage. And the handles were not touching. Usually the handles swing around and touch because you move something, you scooted it or just whatever. No, first thing I saw when I ran over there, I'm like, what's causing this? No, it's not the handles. Nothing moved, nothing was obvious. So I just reached down, unplugged positive, burned my hand very badly. And the only thing that makes sense is that the positive clamp touched the chassis and the chassis is grounded. The whole top is aluminum. There's screws everywhere, but I knew this, so I backed it off the terminal a little bit. I didn't want that positive touching anything, and it certainly didn't arc through the air at 12 volts. So if you have a theory, let me know. I have a theory. Don't use jumper cables. The whole point of this was it was going to be haha funny, don't do this, it doesn't work, because those are cheapy jumper cables that are like maybe 8 gauge and they're like 10 feet long. And based on the brand, it's probably copper coated steel or some other trash tier wire. And it was going to drop the voltage due to resistance to the point where I couldn't even turn on the inverter or it would fail immediately under load. That's what I anticipated happening. Yeah, no. So we're going to use either 4 gauge or 2 gauge wire, like 1 foot of it, and proceed with the video. But don't use jumper cables. Well, it's been a couple weeks. Wired up the equipment a little better here. Hands almost completely healed up. Big burn across there, but nothing I can't come back from. So these are nice and sturdy. No ground out to the metal chassis on the positive. Let's hook it up. So these use normal battery hookups actually. It feels like about maybe a 4 or 8 gauge cable. I'm sure it says somewhere, but it's only 1.5 feet. And that should be able to carry a lot of current. If I'm wrong and they start melting again, which is pretty unlikely, we got the new safe disconnect system for the smaller battery because I can't hook them up because you use square terminals anyway. But yep, that ought to be a little safer. But for the full-size battery, you would just put that right on there and then, well, what do you do if they start melting? Get out a screwdriver, remove it from this, cut it. I mean, you need a solution. The better way to do it is to put a fuse within 18 inches of the battery. But if you ask me, better is kind of relative. Let me introduce you to a battery cutoff switch. And this is different than a quick disconnect switch, because a quick disconnect is just meant to be convenient, not really like an emergency thing. This is more of an emergency thing. So you drop it on here, and then you hook it up to the second terminal. And once it's all nice and tidy, then the way you kill it is by just lifting this. So now it's not a complete circuit. Real simple. This is rated for a couple thousand watts, so I should be good with the amount flowing through here. But yeah, looks pretty solid. It was only $10. All right, left the door open, and you can probably see here 131 watts. I saw it at 138. It's kind of fluctuating a little bit. And like I said with the freezer, I don't know if this is at 100% cooling capacity. It could have like a double power mode like my freezer did if it detects that it's a really, really warm temperature, like you just plugged it in. Also with inversion, you wouldn't want to get close. So would I buy like a 400 watt inverter for this? No, I would go at least 8. And if I had a refrigerator that was metering at 8, I probably wouldn't go 1,000. It's just a little too close. With the aging of the components and, optimistic specifications, let's say, you don't want to get close. You could just buy a 1,500 or 2,000 and say that's the same as my outlet and call it a day. Probably smart. All right, moment of truth. Okay, the compressor stopped running while I was looking for my voltmeter. Still haven't found it. I am convinced with the amount of looking that it disappeared from this realm completely and now exists in a different universe. But yeah, I could measure the voltage right here. I assume that's what those are for. We'll find out when there's a low voltage alarm, because the low voltage alarm will go off very, very loudly, as you heard before. So that'll just let everybody know, hey, I'm still on and operating, but not really, because the voltage dropped to about, what is it, shut off at like 11.4 or something. And that's not a deep cycle battery. So I don't think this is going to run very long, but I've got to wait for the compressor to kick in, and then we'll see what happens. Oh, you hear that? There it is, purring away. It's only got one single LED on the draw meter because, 1 to 200 watts isn't that much on a 2,000 watt inverter. And nothing melted yet. So now we just play the waiting game and see how long this really, really small $40 battery can run our fridge. Okay guys, I found my voltmeter, and I don't know if you can see this or not, but 12 point, okay, well it was 12, there we go, 12.37 volts off of 12.4. So this has been running for, I'd say, 15 minutes continuously. That compressor has not turned off for 1 second, and the amount of energy missing from that battery is negligible. Now you could probably watch this going down in real time. I mean, it's flirting here, but oh, there we go. There we go. There we go. There we go. It just shut off. Okay, one, I was wrong. It's not 12.4, it's 12.6 that it was at maximum charge. And two, it goes back up when it's not under draw, which is good. So it's only a 0.2 drop. And three, we've used up almost no electricity. And I think this probably runs for 15 minutes every hour, maybe, or 15 minutes every 30. I mean, I had the door open to force it, so it runs when it needs to, not on a schedule. So it's all about when did it get warmer? Okay, now it needs to run. Like when it hits a certain temperature threshold. That's how most of them work. So I think we're going to get a couple hours out of this cheap $40 battery. I can't believe that. Well, thought we'd get more time than that. 1 hour 45 minutes. Now the weird thing is, the compressor's not actually running right now. So it just decided to go full low battery on its own. Now it did just fire up the fans for like 20 seconds a little bit ago because it was getting warm. But that's not enough to really draw it down. So it must have just been so low from the last compressor run that just idling this thing, 10, 20 watts, whatever the overhead is, was enough to drive down the battery voltage. So let's find out real quick. Oh yeah, 11.84 volts, and under load it'd probably be 11.5, 11.6, which is enough to trip the low voltage on here. Now, I should mention that I have owned a slightly nicer inverter in the past that would turn off at, I believe, 10.5, so it just had a better range. And with a non-deep cycle battery, you're going to just gradually go down, down, down. And if you want to really scrape the bottom of what's available, you could get an inverter that goes down lower, but the battery's not really designed to do that. Now, once or twice during a power outage, not a big deal. So, I wouldn't do that for daily use. I wouldn't put this in like an electric car or like an electric golf cart or something. Then you would need a deep cycle. That's why they're called deep cycle. But this did work. Also, I bought a little toy for, in case that inverter didn't work, 3,000 watt heavy duty modified sine wave Go Power. Oh yeah, this thing ain't playing. So if this one can operate at a lower voltage, we might have a little something here. Alright, so we're running the battery charger to recharge battery, and it says it got down to 34%. So, an inverter that dips to a lower voltage would not have made a really big difference, but a little bit. Alright, for the big test, we're not messing around. We got the big battery and the big boy inverter. Usually, if you're pulling 150 watts through a 3,000 watt inverter, that is actually somewhat inefficient. However, I really think that the Jupiter one has issues. I got it at a pawn shop. I mean, technically I got this one at a pawn shop too. But this thing retails for almost $600. So there's a little quality difference there. I've never heard of Go Power, but it can't really do worse. So to give this the best possible shot, this is what we're doing. I started the clock. Let's see if we can get like 8 hours out of this thing. That's kind of my goal. I'll let you know what happens. Alright, little update here with the magic of editing. It doesn't seem like it, but 3.5 hours and we're still going. The compressor is running. Oh, I was going to say right now it just stopped. But the watt meter that's supposed to represent the amount of watts on the other side there is at 0 no matter what, so that just doesn't work. I switched it over into voltage mode and it says 11.6, and I thought, okay, we're getting close. Here's the problem with that. Alright, what does the voltmeter say? Oops, it says I got it backwards. 12.74. 12.74, and it was at 12.4 when it was running just a second ago. That's basically full. So, let me take another peek at this. Now, under no load, it says 12.0, so these are 2-gauge cables, but they're about 3 feet long. I doubt that would generate that much resistance. So let's take a gander at that, shall we? At 12.71 at the terminals. So it's not cable resistance. I think that the monitoring system on here just isn't very good. Well, that's good for us because this battery's going to last a long time. But way more importantly, $1.47, 75% off for a steak for sirloin? Bro, I got to call Danny and figure out like where you can do this. So even if this runs for 8 to 12 hours, which I think would be good, what if you have like a 3-day outage? Or what if you want to just run this nearly forever if there's a 1-week-long outage? I would say you could start your car, rev it up to about 2,000 RPM to max out the alternator, then hook up that battery with the shortest cable you can, preferably not jumper cables, because you can get that a lot closer to your battery. Just set it like right around on top of your radiator, like that area, on the frame. And then it should take, I hate to even throw out a number, but like less than an hour to charge it up because that's a lot of amps coming off of there, especially at 2,000 RPM. Now you're going to burn some gas. Don't do it too long. You're going to blow up your lifters in your car, but we're talking a couple hours might do that just for oil and stuff. It's complicated, look it up. But yeah, you could just use your car to recharge that battery pretty quick. Otherwise, if this is drawing 130 watts for, let's say, 15 minutes out of every hour, then to run this continuously, you would need 1/4 of 130 watts going into that battery at the terminal at the same time that the electricity is going out. Or have 2 of them and swap them and go charge them. How you would do that? Well, I got a little idea here. This is going to be a separate video because I don't want to get too crazy with the scope on this, but I also got this at the pawn shop. Neat little new toy. So subscribe if you don't want to miss that. And honestly, this is the most expensive video I've made in the history of the channel. I'm into the like 700 range, I think, at this point. I know this is going to help a lot of people, and I think it's going to be really popular. So do please leave a like, send it to all your friends, and leave any tips and tricks down in the comment section if you want to help out. But additionally, just go check out my other content. We do a lot of really cool stuff with electronics and stuff that other prepper channels don't do. A lot of chemistry, a lot of food stuff, a lot of biological stuff, nuclear tips, all that kind of sciencey stuff that you just don't find elsewhere. So I would love it if you guys would help me keep this channel going by supporting it just by watching. But yeah, this is rated for 45 watts. We're going to test it in a future video. Okay, guys, we are now 2 minutes short of 8 hours on the dot. I checked. It is still cold. It is still running. It's still pulling. They're saying 11.3 on that completely inaccurate meter. My very accurate meter says we're at, check it live here, 12.36. Wow. I mean, at this rate, I'm going to say this could run for like almost 24 hours. Just short of it. Unreal. I am completely blown away. So, I mean, this is the setup right here. And remember, if you meter your fridge at like 150 watts, like this one. Oh, sorry, we got the air fryer going. Yeah, I'm cooking one of Danny's steaks. I mean, he got like 12 steaks for like $3. Like, what? I don't even know where this guy shops. Well, I do have to go home at some point because I got to work tomorrow. And I need my laptop that's back at my house. So we're probably going to have to turn this off so that the alarm doesn't magically go off at 4 a.m. if that's when it runs out of power. And resume tomorrow. Unreal. Absolutely unreal. Well, I'll wait until the steak is done. By the way, he's got a really nice air fryer. Okay, this one's big, you guys. Right when the compressor kicked in, we got a low voltage chirp for just 1 second, and then it stopped, and then 1 second again, so it must have kicked up again, and then stopped again. So we're not going to make it that many more cycles. Unfortunately, it says 11.3 volts on the voltmeter on the other side of the inverter right there. And if it's using that as absolutely the reading and it's turning off because it thinks it's too low, that sucks because it's wrong. I measured the voltage once again at there. It's above 12. So that means the battery's got a lot more juice in it, and that sucks. Because we're going to lose a lot of time to that thing just being incorrect. Now, if the internals don't operate below like 12, okay, and they're actually turning off and the voltmeter is just read-only and it's not considering that as part of like a digital control, that's another story. But I am not happy with this inverter. So now I am not happy with both of my inverters. And with what I paid for both those inverters, I could have just gotten a really good one. Like a really reliable one with good clean capacitors, brand new. Yeah. So don't trust used stuff. But this did work, and I'm pretty impressed that it's been over 8 hours. So we'll see how much longer this runs. I think the very next time it turns on might do it. All right, day 2 of running this off of the battery. We're approaching about 12 hours right now. The battery's at 11.32 volts, but it's displaying, I think, 10.7 over on the inverter. Hopefully that's not what it's using to determine when it should shut off. I hope that's just a display. It's for read-only purposes, and it's not part of the operation of any kind of computer chip inside of the inverter. Now, the other interesting thing is I looked up what the shutoff voltage is, and that inverter is 10.5 volts, which is absolutely wonderful. That is a really good low range. I also found out that you really can't buy that particular inverter for under about $500, and we're talking used on eBay. The thing retails for upwards of $1,000. So the question is, when this is all over, do I keep it or do I keep the Jupiter one? This thing's 85% efficient according to the specifications. It's greater than or equal to 85%. I haven't heard any low voltage chirps, so I don't know what happened with that. I don't know. But we're just going to run this thing until it stops. I am so impressed by this. You could probably get upwards of a day out of this battery, and that's without doing anything to recharge it at all. Unreal. Alright, there it is. We're going freehand here. That is the low voltage alarm. Switching it off, grabbing the time. I'll get the statistics in post. So 15.3 hours runtime versus 1 hour 45 on the non-deep cycle lead acid battery. $40 versus about 110. Guess which one I'd recommend buying? I just bought that one because it was really lightweight, and I thought, well, let's see what we can do. And it did have the amount of output electricity to run a fridge. If you're going lead acid, always go deep cycle. You have to do that, or it will dip the voltage way too soon. Now, lithium, it is just absolutely straight line and then off a cliff. It does not slowly go down like an alkaline or a lead acid battery. Or nickel cadmium. That's why everybody loves them, because you get the most out of them. They're much lighter, but that's really the only advantage. They're more fragile, they're more sensitive. You have to charge the cells with a chip that tells them to balance them, and that doesn't always go well. And then if one cell goes wrong, you got a bad battery. They're complicated, and the only thing they have going for them is how light they are. They cost more. They're just more annoying to babysit. They're more sensitive. They don't like heat. Lead acid batteries are workhorses, just get a deep cycle one. So this one's 70 amp hours and the smaller one was, I think 20 or 30, somewhere in the neighborhood. So you would have expected it to run for 8 hours. No, that is the difference with a deep cycle battery. They are designed to do this. You will get what they call more charge cycles out of a lithium, but you're talking a couple hundred versus a couple hundred more. I don't think you're going to have to power your fridge off this 400 times. So as long as you don't mind lugging around a 40-pound battery or whatever this is the answer. And then you can put them in parallel. You get multiple, and it'll run for double the time. Need some pretty thick cables to do it, but that's how you do it. Positive to positive, negative to negative. Get some zero gauge ring terminals. That's why the batteries have 2 terminals to put them together like that, and you're all set. Look up a video on how to do that, though. It's a way better idea. And the one thing, I outlined in here, is always put a cutoff switch and a fuse. You want the fuse to blow when it's unattended, and if something goes wrong and the fuse doesn't blow because you can't count on it, you want a kill switch. And, loosening a nut while the stuff's on fire, and smoking, and then trying to pull it off the terminal, nah. You're going to have a thermal runaway and your place is going to burn down. So always have a kill switch. So if you got the money, go lithium. But I will say that battery was $110, and a good lithium battery, a really good one, is $400 to $1,000, depending upon the capacity what you get. You can get some commercial rack mount ones and stuff, but you get questionable soldering and who knows what Chinese brand. And then they're really good, but then they make them differently later, and then tariffs, and it's just a whole thing. I want my good old lead acid, okay? You can count on it. That's the way to do it. And it will cost you more money even if you do it yourself to build a lithium battery. So let's compare this to a generator. A cheap generator is garbage. You need to oil change them about every 24 operational hours for a low-end one. Look it up. It's in the manual. And a really good generator is upwards of $1,000 to $2,000 for sure. Those famous little lightweight red Honda ones that can barely hold any gasoline, but they're really quiet and portable. They last forever and everybody uses them. Go get one of those used on the secondary market, we'll talk. But the fumes, and then you got to run like an extension cable, then there goes any kind of OPSEC because everybody can hear it. And then you run out of gas, or you get sour gas in there, you have a bad, this, that, or the other thing, a bad piston seal, a bad spark plug. It's so many parts. This is so much easier, more durable, about as portable weight-wise, except the sun never runs out of gas. And where are you going to go get gas? So unless you've got like some crazy dual fuel propane hybrid one or something, I am never buying a generator. There's no point. They're just stupid. They're unreliable. They never work. People never start them up every 3 months to make sure they work. They don't know small engine repair. I barely do. They're just a disaster. They're awful. You can't rely on them. This ain't going anywhere. You put a little tiny float charger, a little $10 charger on this, it'll always be topped off. It'll always work. And the inverters are pretty solid. Those things can run for decades. I know which one I'm picking. And like I said, you don't need solar to charge that battery. You could use wind. You could use your car. Just any source of electricity. If you can get it up high enough and charge it safely with a charge controller, you're good to go. The only thing you have going against you is the weight, and the battery's not that bad. So hey, any DC electricians, leave the comments down below about little things that I got wrong or little optimizations, better things you could do. I'm not a specialist, I'm just intermediate level at this kind of stuff. And I always appreciate the group effort, but my hand is healed up. It was a really fun week trying to use a mouse right-handed. That was great. But I've been burned way, way, way worse by cooking oil. Just little individual drops in the air from dropping in something that was a little bit too wet was way worse than this. So I certainly didn't fake it, but it healed up in about a week and a half. So pretty weak little burn. I just, wrapped it up, put lidocaine on it and said, oh, I hope this isn't too bad before I even really got to look at it or if it blistered. But if you appreciate the budget and the effort and everything else, good information in this nice, long, appropriately edited video with all the information you need instead of some 2-minute something where you're going to try it yourself and burn your house down, that's what we do on this channel. So stick around and check out the rest of my cool videos. I appreciate you for watching, and I'll see you guys next time.